If you've been scrolling through tech Twitter or YouTube lately, you've probably seen the absolute explosion of image to 3D models. Type in a prompt, out pops a flawless 3D mesh. And so, when Meta dropped SAM 3D, the internet did what it always does. It yawned, tossed it into the bucket labeled cool 3D asset generators, and moved on. But they completely missed the point. SAM 3D is not a tool for game developers to make pretty 3D chairs. In fact, if you judge it purely on how clean its 3D assets look, it actually looks worse than some of its competitors. But that's because SAM 3D isn't an asset generator at all. It is Meta's bid to build a foundation model for 3D perception. While everyone else is trying to teach AI how to hallucinate virtual objects, Meta is teaching AI how to see and understand the physical world. And the implications of this for robotics, AR glasses, and the entire AI race are massive. To understand why this matters, we have to look at the architectural divide between prior heavy asset generation and visually grounded perception. Tools like Tripo or Trellis use massive datasets to guess what a complete, isolated object looks like. They don't care about the room, the lighting, or the context. Their only goal is to generate a pristine OBJ file. It's a hallucination machine. A brilliant one, but still a hallucination. Now, look at what SAM 3D does. If I put this mug down behind my laptop, a normal vision model just tells you, there is a mug. SAM 3D looks at this messy, uncurated, cluttered scene from a single camera angle and instantly extracts three things: the exact 3D geometry, the raw texture, and, crucially, the camera relative layout. It doesn't just guess what a generic mug looks like, it infers how this specific mug is oriented in three-dimensional space, even when half of it is blocked from view. Meta released this in two distinct flavors: SAM 3D Objects, which handles scene reconstruction, and SAM 3D Body, which tracks human meshes. They aren't trying to help indie devs build video games faster. They are training an artificial brain to understand that even if a chair is partially obscured by a coffee table, it still has four legs anchored to a physical ground plane. They are teaching machines spatial common sense. Now, let's talk about why this is happening now. Because the biggest bottleneck in 3D AI has never been the neural network architecture. It's the data. Think about it. The internet contains trillions of text tokens for LLMs and billions of 2D images for Mid-Journey. But how much high-quality, real-world 3D ground truth data is floating around on the web? Almost none. Scraping 3D CAD models from CAD repositories doesn't help an AI navigate a messy living room. So, what did Meta do? They built a data manufacturing plant, borrowing the exact same playbook from the original 2D segment Anything project. Meta created an interactive annotation engine. By combining manual 2D keypoint tagging, multi-view geometry, and differentiable optimization, they turned standard flat images and videos into hyper-accurate 3D training data. The result? They annotated nearly 1 million images and generated roughly 3.14 million meshes. That number is the real breakthrough. While other labs are fighting over the remaining text data on the web, Meta just figured out how to synthesize their own 3D data moat out of standard flat 2D video feeds. It's a closed-loop data engine that can compound for years. While the tech world was busy looking at the object reconstruction side, they completely slept on the real masterpiece of this release: SAM 3D Body. For over a decade, the gold standard for tracking human bodies in 3D was a framework called SMPL. It was groundbreaking, but it had a massive flaw. It tightly coupled a person's skeletal structure with their soft tissue and shape parameters. Meta introduced something entirely new called the Momentum Human Rig, or MHR. MHR cleanly decouples the underlying skeletal joints from the external surface shape. It estimates body pose, hand pose, foot pose, and shape parameters simultaneously, remaining incredibly robust, even through unusual poses, heavy clothing, or extreme occlusions. Why does a robotics company or an AI lab care about this? Let's map it out. If a humanoid robot company wants to train their robot to do tasks, like fold laundry, load a dishwasher, or lift a heavy box. The fastest way to train them is through imitation learning. You show the robot thousands of hours of YouTube videos of humans doing those tasks. But with the old models, if the human in the video was wearing a baggy hoodie, the AI would get confused and warp the skeletal data. With MHR, the AI strips away the clothing and isolates the raw, pristine human kinematics. It turns ordinary internet videos into structured high-fidelity motion data that can be mapped directly onto a robot's rigid metal actuators. It is a cheat code for embodied AI. But look, this channel isn't an uncritical hype machine. To give you a truly ruthless breakdown, we have to talk about where SAM 3D absolutely hits a wall right now, because the research papers and curated demos always show you the best-case scenarios. First, SAM 3D body is heavily biased toward front-facing subjects. The moment a human turns completely sideways or assumes a highly contorted position, the limb distortion starts to creep in. Second, the hidden surfaces are still just educated guesses. If an object is 80% blocked, SAM 3D is using its learned priors to infer what's back there. It's a very smart guess, but it's not true observation. But the biggest structural limitation? The single object bottleneck. Right now, SAM 3D predicts structures one masked object at a time. It doesn't inherently reason about multi-object physics. Because it lacks that contextual physics engine, a reconstructed room often suffers from what engineers call ghosting, or clipping, errors. Objects might float a millimeter off a table, or slightly intersect with a wall. It knows where things are, but it doesn't yet fully grasp how they physically rest against each other. When you zoom out and look at the macroeconomic landscape, the battle lines for the next decade of AI are being drawn clearly. OpenAI's Moat is cognitive reasoning. Google's Moat is vast multimodal knowledge. NVIDIA's Moat is the computing canvas and simulation. Meta's Moat? It's world understanding. Every future embodied AI, every household robot, and every pair of AR glasses needs a real-time, low-latency 3D world model to function. They need to know where to step, what to grasp, and how to navigate physical space safely. By embedding tools like SAM 3D into their ecosystem, from consumer applications like Facebook Marketplace view and room features to their hardware pipelines, Meta is turning their massive user base into a global telemetry loop. If GPT was the moment language models learn to comprehend text, SAM 3D is a foundational step toward machines comprehending physical reality. Stop looking at the mesh quality and start looking at the infrastructure. Meta just built the eyes for the machines of tomorrow. Let me know in the comments below. Do you think Meta's bet on physical embodied AI will outlast the pure software play of their competitors? Hit subscribe for more deep tech breakdowns, and I'll see you in the next one.